Tables of E-values are not easy to come by, and even when you do find a table, it may not contain the salt you're looking for. It's convenient then to be able to derive your own E-values based on only your knowledge of a salt's molecular weight and its number of ions. The top part of this slide shows how the formula for estimating E-values was derived, and it's only included here for those who are interested in knowing how the equation connects back to osmoles. The final formula for calculating an E-value is in red and does need to be memorized for the assessment. This formula states that the E-value of a salt is 32.5 times the I factor of the salt divided by the salt's molecular weight. Theoretically, the I factor of a salt is equal to its number of osmoles per mole, but salts don't really dissociate 100% into their ions in solution. So the I factor actually is somewhat less than the osmoles per mole of a salt because it takes lower levels of dissociation into account. I factors are sometimes determined from experimental observations of the extent to which a salt dissociates. If experimental data are not available, the I factors shown in this table are used, where the I factor values are based on the numbers of ions in the salt and assume 80% dissociation of the salt. You'll need to memorize the top 3 I factors for use on the assessment. The calculation above the table is there for informational purposes only and shows how an I factor is derived. All right, the first example question asks, what is the isotonic concentration of boric acid with an E-value of 0.52? This is similar to a problem we did before where we were trying to find the isotonic concentration of potassium chloride. And this time we'll do the same thing. We'll take the isotonic concentration of sodium chloride and we will replace the grams of sodium chloride with the equivalent amount of boric acid. So we'll take the E-value of boric acid, 0.52 grams of NaCl per gram of boric acid, and we'll ask how many grams of boric acid are represented by 0.9 grams of NaCl. And we will crisscross and solve for x, and x is equal to 1.7 grams boric acid. So if we put 1.7 grams boric acid in for 0.9, we get 1.7% boric acid, and that's equivalent to 0.9% NaCl, and that's the isotonic concentration of boric acid. In the next problem, what is the isotonic concentration of this drug xylometazoline hydrochloride, which is a 2-ion drug salt with a molecular weight of 280.84. We have a molecular weight, and we have the number of ions. We don't have an E-value, but we can use these values to determine what the E-value would be. So the equation we'll memorize is 32.5 times I over molecular weight. And we will put the I factor in for a 2-ion salt, which is 1.8, which is another thing to memorize. So 32.5 times 1.8 divided by the molecular weight gives us an E-value estimate of 0.21. And so now the procedure is just like for the problem above. We're going to try to find the equivalent number of grams of this drug that are equivalent to 0.9 grams sodium chloride. So E-value is 0.21 grams sodium chloride over 1 gram of drug. How many grams of drug equal 0.9 grams sodium chloride? Crisscross. And x is equal to 4.3 grams. We put that in for 0.9 grams. So 4.3 grams of the drug in 100 mils is the percentage. It's 4.3% of the drug will be the isotonic concentration of that drug.